Simplified. This is the second episode of Arithmetic Progression. So while I was recording, I realized that this episode is a bit lengthy, and because of that reason, I'm splitting this into two parts. So in the first part, I'll be explaining till the explanation on some of arithmetic progressions. On the second part, I'll be explaining some of the problems. And we are also having a third episode for arithmetic progression that will be discussing the advanced level problems. So we'll be going to the problems directly. Thank you.
So we are on our second episode. We are going to the problems directly. So our question is 301 is a term of sequence 5, 11, 17, 23. We are given a sequence and we are asked to find out whether 301 is a part of this sequence or not. So the first step what we are going to do is that we are going to write down the things we know. So we have already given the sequence, which means that we can find out A. A means the first term. So here in this case it is 5. So first term is 5, or otherwise A is equal to 5. Now we are going to find out what is the common difference. So for finding out common difference, you can find the difference between either 5 and 11 or 11 and 17 or 17 and 23. In all the three cases, you are going to get the answer as 6, which means that common difference is 6, or otherwise D is equal to 6, which I have already written over here. Now we know one equation. It is the equation of arithmetic progression. I started discussing about this equation from the beginning of the first episode. So that equation is an is equal to a plus n minus 1 into d. So we are asked to find out whether 301 is a part of the sequence or not. So we are going to do one thing. We are going to substitute the non-factors in this equation, assuming that 301 is a part of a sequence. If that's the case, upon substituting, we'll get the equation like this, which means that instead of a and we have to replace it with 301. For a, we know that its value is 5, and for d, we know that its value is 6. So if this is the case, we know that there is only one factor we don't know yet, and that is called as n. So n is giving you which term is going to be this 301. So which means that if we are going to get n's value as a positive integer, then that essentially means that it is the part of a sequence. But otherwise, if you're getting it as a fraction in between positive integers, like for example, if you're getting 5 by 2, upon simplification, we'll get to know that it is 2.5. So eventually it is saying that is 2.5th term. So there is no term like that. It should be a positive integer. It might be a term called as second term, or it might be a third term or fourth term or fifth term, but will not be anything in between these positive integers. So upon simplifying this equation, we need to check whether the value what we have got for n is a positive integer or not. That is the only thing that we have to do here. So upon simplification, we know that 301 is equal to 5 plus 6n minus 6, because what we are doing is 6 is being taken inside, so 6 into n, it is 6n, minus 1 into 6, so it is minus 6. So that is the reason it is coming to 6n minus 6. And upon further simplification, what happens? We are going to take this numerals into the left hand side and only keeping n related terms at the right side. So 6n is on the right side and minus 6 will be taken to the left side, so it will become plus 6, and 5 is being taken to the left side, so its sign changes, so it is minus 5. So upon further simplifying, we'll get it as 302 is equal to 6n. In other terms, n is equal to 302 divided by 6, which is obviously a fraction. We can only simplify it one time, so we'll be getting the answer as 151 by 3. It is not a positive integer, and because of that reason, this is not the part of sequence. Okay, so this is the first problem. Now we are going to the second problem. So our question is, it's a very simple one. How many 2 digits are divisible by 4? So I repeat, how many 2-digit numbers are divisible by 4? To do this, first we need to bring two-digit numbers into our attention. So the first two-digit number is, of course, it is 10, starting from 10, then 11, 12, 13, it will be going all the way up to 99, which is the last two-digit number. So I'm going to write it down for your simplicity. So this is how it somewhat looks like. But question specifically asks, it is not just the two-digit numbers you need to find. You need to find how many two-digit numbers are divisible by 4. So you need to specifically find out those numbers that are divisible by 4 here. So if that's the case, we know that 12 is the first term that is divisible by 4, because 10 it will not be going, 11 it will not be going, 12 it goes 3 times. When it comes to 13, 14, 15, no, but 16, yes, it goes 4 times. 17, 18 and 19, no, but 20 goes 5 times. And likewise, 96 is the last term that is divisible by 4. The last two-digit number that is divisible by 4. But afterwards, 97, 98, 99, it won't be divisible by 4. So this is the sequence we are looking for. That is 12, 16, 20. It goes all the way up to 96. So we got the sequence. We only need to find out which is the term that is yielding 96, or which term is going to get you the value 96, or in simple terms, find out n. Which number of term will give you 96? So we already know a in this case. So a in this case means it is going to be 12 for sure. That is the first term. Difference, we just need to subtract 12 from 16, so you'll be getting 4. And an, as usual, we are going to fix it as 96 because that is the last term, and we need to find out what is its n. So we already know the equation using for it. N is equal to a plus n minus 1 into d. Now we need to substitute all these values. So the equation will looks like this. So n is equal to 96, a we already find out it is 12, d we know it is 4, and we don't know. N is the one we are going to find it out here. So next step, what happens? 96 is equal to 12 plus 4n minus 4. So 4 is being taken inside. So that's the reason it is ending up at 4n minus 4 over here. On next step, we are going to take all the numerals to the left hand side and all the n related terms at the right hand side. So what happens is minus 4 when going to the left hand side will become plus 4, and this 12 will become minus 12. So upon next simplification, what happens? It will be getting into 88 is equal to 4n, or in other words, n is equal to 88 divided by 4, which is equal to 22. In simple words, there are 22 two-digit numbers that are divisible by 4. So that's a very simple question. Now we are going to the next one. The next topic which I'm going to take is sum of arithmetic progressions. But before going to this topic, I would like to give you a small story, which is actually a real incident, and it's also been in many textbooks. So you might find it familiar, but for your kind information and knowledge, I'm explaining it once again. So please listen to it. It's a very short story. A maths teacher, when she came to her class, realized that she has to complete some urgent works. So she decided to give some activity to the students to make sure that the students are not interfering with her works. So she asked the students to find out the sum of 1 to 100. So her calculation was students are going to take some time to find out the sum of 1 to 100 by the time she can complete her work and can start the class immediately. But proving her calculations were wrong, a bright student came up with the answer within a very short span of time, saying that the sum of 1 to 100 is 5050. Listening to that answer, teacher was quite surprised. She asked, "How do you got that answer?" The student given a very interesting explanation, a very convincing one, to make sure that what he did was correct. And that explanation is the thing which I'm going to explain right now. So if you got any good idea regarding how he find out that answer, post the video right now and try to find it out yourself. And once you find it out, then resume from that portion. So it might be giving you some real good brain exercise. So I'm going to tell you how the student find out that answer. So the student started writing 1 to 100 from left hand side to right hand side. Then he repeated that same process in the reverse order, starting from 100 going all the way up to 1. Now he started adding up the pairs one by one. For your better understanding, each and every pair is being given in different colors. So when he found out the first pair, he got the answer as 101. For the second pair too, he again got 101. For third pair, it's the same. For every single pair, he got the answer 101. So virtually 101 is actually repeating 100 times, which means that you can multiply 101 with 100, which will be giving you 10,100. But this 10,100 is actually the sum of two pairs of 1 to 100, as you can see from here. So if you want to find out the sum of 1 to 100 for one single pair, you need to divide this 10,100 by 2, which will be giving you 5,050. And this is the explanation student given to the teacher. But the teacher was still skeptical with that explanation, so she started adding up 1 to 100 to verify the answer is correct. And this bright student came to be known as one of the famous mathematicians named as Carl Friedrich Gauss. And this explanation is going to help you in finding out the equation for sum of arithmetic progression. So first step, what we are going to do here is we are going to represent any sequence in a universal format from first term to the last term. So this is how you represent it. So sum is equal to first term plus second term plus third term up to the last term. This is the equation for the sum in simple terms. We are going to do this in exactly the same way Gauss did this calculation. Okay, so the first term, as you already know, it is a itself. If you need to find out the second term, you only need to do one thing. You need to add the first term with the common difference, then you will get the second term. So that is what exactly we did it here, a plus d. Now if you want to find the third term, we need to find a plus d or otherwise a plus 2d. So this is a representation of a sequence in a universal format. So the last term will be, obviously it is an. We already know the equation for an. We've been discussing this all the way in the first episode. So an is equal to a plus n minus 1 into d. So this is how we are representing the sequence. And now we need to do the same process Gauss did for the second step. We are going to represent it in the reverse order. So reverse order means our first term now becomes a plus n minus 1 into d. So this is how the second sequence coming. Sum is equal to a plus n minus 1 into d. Then next one is some other term. Okay, I'm not representing it right now because anyway you're going to get the same sum for every single pairs. So that's the reason I'm not writing everything. And likewise, when you're going, the last term will be a. So if you find out the sum of each and every pair, you'll get the answer like this. So when you are adding s plus s, it is going to be 2s. A plus n minus 1 into d, you'll be getting it as 2a plus n minus 1 into d. Here also the same way I'm doing. I'm representing each and every pair with different colors. And the last pair also you'll be getting exactly the same answer as here. So you can add a plus n minus 1 into d plus a, which is 2a plus n minus 1 into d. So in short, this 2a plus n minus 1 into d is repeating n times. Here it was 100, but here in this case it is n times it is repeating. So we already got the equation. So now we need to find out the multiplication of 2a plus n minus 1 into d into n, because it is repeating n times. So n into 2a plus n minus 1 into d. So in simple way we can represent it as 2s is equal to n into 2a plus n minus 1 into d. So if you want to find what is s, just take this 2 into the right hand side. So which means that you'll be getting it as s is equal to n by 2 into 2a plus n minus 1 into d. this is how we have find out the equation for the sum of arithmetic progressions, and we are going to use it throughout this chapter. Now we are going to remodify the equation of sum of arithmetic progression into another format that is going to be very simple. So we know that the equation for sum is s is equal to n by 2 into 2a plus n minus 1 into d. So I'm only going to do one single step. I'm going to separate this 2a as to separate a, which means that like this. So instead of writing it as 2a, I written it as a plus a. That is the only difference I made. But right now, when you take a look at this point, you see something really familiar. That is a plus n minus 1 into d. And we know what is a plus n minus 1 into d. It is of course an. So we are going to replace that an right here, which means that our equation is compressed into s is equal to n by 2 into a plus an. So an is the last term, or in other words you can represent it as L also, which you should know that is actually the last term. So we are going to use this equation in some certain situations, like if you have already given the first term and last term, and also you know how many number of terms within that sequence. So in that case you really don't need to find out the common difference. Instead you can directly apply this equation and find out the sum. So this is how we are finding out the sum without knowing the common difference within the sequence. We can write in this way also, but make sure you know that this L is the last term or An is the last term.